Okay, so today we will move on to the new topic of refraction of light. Jahangir, what does refraction of light refer to?
Refraction of light is when refraction is when a wave goes from denser medium to less dense.
It goes from denser to less dense medium, that's refraction.
No,
Change in the direction of the
So change of the angle of the ray because of change in the medium density.
And what does that cause? It causes one change in the wave's property.
It's
So changes the wavelength, decreases rate.
Speed.
Very good, very good. So whenever the speed of a wave changes,
The wavelength also changes.
when going from one medium to another, when it goes from one medium to another, and that too one more small correction is there. If you have two medium like this, if you have two media separated like this, every marker is on it. If the wave is going at normal incidence, then will it bend?
Never.
So you have to mention this point. Whenever a wave has an oblique incidence on the interface between two media which have different optical densities, which will cause a change in speed, then that wave will bend due to the change in speed, which is called refraction. This gives rise to many cool effects. So one such cool effect is invisibility. So let us see that demonstration. Ideally, I would have liked to do it. I'll do it in some other class. I didn't get time to set it up.
So can we like actually walk around invisible with this? So can we walk around invisible?
One second. Have you seen the movie Predator? You have seen Predator?
I see Mr. India.
Mr. India, there the concept of how he achieves invisibility is not clear.
So turn on the subtitles.
So English state as a
Subtitles?
Yes, sir.
Auto generated, sir.
Who is asking for subtitles?
So everyone, so
So what happened in Predator?
Well, I'm Bruce Hayden. Today I'm going to show a very old demonstration, but it is one of my favorites when we're looking at index of refraction. It has to do with corn oil.
Subtitles are horrible. It's more distracting than useful.
Please,
I warn you.
So please, sir, at least he'll learn something, sir.
Teacher's decision is final when it comes to what is
we'll have to get head down.
Okay, now let's be attentive.
So increase the
So
volume.
It has to do with glass. And it also has to do with a broken test tube. So let's set up a backdrop so we can see this easier and take a closer look. Alright, now this experiment's going to start with two containers, and this first container I'm going to fill up with water. Most of the way, there we go. That's about right.
Wait. Avi, what is filled in the first container?
And the second container I'm going to use corn oil, about the same amount.
Which oil?
corn oil.
Who is that sleeping next to you? David? Ramaputra. What is filled in the second container? Huh?
I'm telling you one thing, is a very stupid one.
You asked your neighbor and said, cheating. Corn oil, okay. Now this is the problem. No, if I need to do it for you, I have to get the proper oil. It takes time. So I'll do
This is
some
an
other
order
time.
from CDH.
Now that we have these containers ready to go, the next step is I'm going to add an empty test tube to each one. We'll put one in the water first, we can see it, and I'm going to fill it up with water. There it goes, and we can still see it very plainly. Now let's.
What? Nobody is looking now. Okay, Arif Prakash, what did you observe when the test tube was put in water?
So then the water went over and filled inside the test tube.
And you are able to see or not able to see?
So kind of. You can have
So you can see the outline.
You can see the outline of the test tube. Okay.
Let's try one in the oil.
Now see what happens next.
Let's put it in the oil. You can see that very plain.
Tell me your name, I forgot, I'm sorry.
Harsh.
Huh?
Harsh.
Harsh?
Yes, sir.
Okay, Harsh, what did you see when you just put in the corn oil?
So it's very faintly visible.
Not very faintly visible, it's clearly visible. Even now test tube is clearly visible. This is an example of how what you expect to see is influencing your observation. You expected it to disappear, but still it's not disappearing, so you are adding it and saying it's faintly visible. So please restrain from such
Guys,
Let's build up.
What?
so what is the question for our internal assessment?
Short talk.
We'll answer the question later, okay? Don't worry.
भाई स्नीक अपना मुंह बंद करो.
And the test tube.
Where did it go?
The oil filled it. Yes, sir.
Once the oil entered the tube,
Vanished.
Here.
vanished.
Now let's see that again.
Where is this glass test tube? Where do you see
There
it?
it is. Plain as day. You can see it very easily. Let's try the oil again.
I still see it.
Well, you can see it very plainly. The concept fills up with oil.
I see it.
Index of
Just like the
refraction. Now you take both pen light the same way at the same angle. So that's what's making it hard to see the test tube inside the oil. Now that you understand this concept, you're going to take this broken test tube and make the oil appear to make it whole again.
Do what?
Now this is a fun demonstration that I do in my classroom sometimes. It starts with that container of oil again.
You can hide stuff there.
And my broken test tube is in two pieces. And we're simply going to take them and add them to the container of oil and see if the oil will restore the test tube back into one piece.
You understood the way I do it as a magic trick is? See, that's the difference between YouTube and real life. In YouTube, he has found the oil which has exactly the same refractive index as that glass test tube. And so when the glass test tube is filled with oil, what happens? If this is the glass, if this is the glass wall, and if inside and outside you have oil, and oil, glass wall, everything has same refractive index, will the light rays bend? So they will not bend. So if your eye is here, if light from this side is passing through this, it doesn't bend at all while reaching your eye. So your eye doesn't detect any change in the path of the light ray, so you cannot detect the presence of the glass test tube. But when I try to do it for you, I cannot, it's very difficult to find that exact oil which has the same refractive index as the glass. It will be slightly different. So you will end up seeing the glass a little bit at least.
I have a question.
So the magic effect is not so perfect, but he has got it perfectly correct.
So imagine if, sir, we find something like a liquid like this, which is transparent and has the exact same refractive index as us.
Okay.
Then we
If you are swimming in that liquid, you won't be visible. But by the way, you are not transparent first of all.
Oh my god.
You are opaque. So you can't become
No, but I
invisible.
have one more question.
What?
If we attach mirrors and cameras to us, so that when the light is coming here, it shows what is at our back, and when somebody is looking at the back,
Yeah, that can be done.
so we'll be
So
invisible.
the computer has to calculate everything in such a way that whatever direction light is coming and entering towards you, same way it should be reflected, it should be transmitted back. It's a very complicated thing. It's a hypothetical possibility.
So can you
To
explain
make it practically work is very difficult.
Can you
Yes,
explain the mechanism of how the test tube disappeared?
that's what I explained just now. The test tube doesn't appear to us if it does not change. What?
This use the test tube.
Yeah. If I take a test tube and hold it like this, would it become like a test tube? Yes or no? Okay, is this a test tube? Is this a test tube? If I invert it, if this summer heat, all the marker pens are dried up. I'm not. Can you get some marker pens, black and blue? Okay, so Aryan Chaudhary, did you understand why it disappeared? No. See, it disappeared because it's not able to bend the light rays when they pass through it. Because the light ray will bend only if the speed of light changes while traveling from one medium to another. Since the speed doesn't change because yes. So it just travels as if it's coming in one medium. Red and green are the worst colors possible. I need black and blue.
That's fine for you.
But if the light is
See, through transparent medium, if two medium have same refractive index, is exactly as if it's one medium. So it's like you're just looking at water, not glass.
Light is coming through the test tube and we should be able to see the test tube.
How can you differentiate test tube from the surrounding water? There is no bending of light when light travels from water to glass and glass to water. So glass behaves like water. So it appears like water. So you can't differentiate glass from water. Both are transparent and they don't change the light in any way. Got it? So the way he is doing it as a magic trick is, he will already put a full glass test tube inside this corn oil container. Make those Tegvir, Raghamudra. So that doesn't mean you can sleep. You are not in a movie theater for your information. You can't sleep as you wish. Deciding which is important, which is not. I'm sorry. Please realize what is expected out of you in a classroom. I can repeat the same thing 10 times. You have to listen. You can't go to bed. You didn't pay for a movie ticket and came to watch a movie. If some scene is boring, you can doze off. When the fight starts, you will wake up. You don't have the choice here, I'm sorry. Do you realize what I'm saying is correct or not? This is not a movie theater. It's your duty to be fully attentive for the whole class. I'm not teaching you one-on-one, right? I'm teaching everybody. There will be some students who need repetition. You have to listen when I repeat for their benefit.
So can we move on?
Okay, since Devya seems to know everything, you tell me what is the plan of the magic trick here?
That's the magic trick. First of all, the test tube is transparent and it has kind of the same refractive index of
I didn't ask you to explain anything. I asked you what is the plan of the magic trick. That means what does the magician want to do? How does he want to show a magic? What does he want to do?
Show that the light doesn't stay direct.
I'm not asking the concept. He's not a physics teacher. As a magician, you want to do a trick and surprise the audience. What is it he wants to do?
Make the test tube invisible.
No. So that's why, and you are sniffing. That's exactly what I'm trying to explain and you slept off. So the magic trick which he wants to convey was, he is already feeling. No. So listen please. You haven't heard me speak, so you don't know what is the magic trick which is called. That is very spectacular. Instead of just making it disappear, that is one way. Something even more spectacular is what he is planning. So already he has put an unbroken glass tube inside which you cannot see. So you are thinking that it has only corn oil, nothing else. Then he takes a broken test tube. Okay, and then he says he can chant some magic, and once he puts the broken test tube inside, and if he takes it out, it will become whole again. So that's what he will do. He will take the exactly, but you don't know that.
So you've done this to us.
So I did this. Oh, great. That means there are some students who have seen it. So
हमारे सी फॉर्म में
अगर नहीं किया, some C-form I have done it before, right? That's it. So he was there, you were not there in my class. तो इसे क्या सबने में देखा इसमें? So suppose you have two pieces of glass test tube in front of you. I'll break it. I'll break one test tube into two pieces and put it in this. It will disappear. So I'll say, oh, Bhagaram, Sula, Sunamam, Chubadam, Thu. And then I'll put my hand inside the liquid. That's a magical chant. Only you can repeat the chant. So you will use it to make all broken objects.
Come on, to repeat it, please.
No. There are many things which you cannot repeat. Okay, so
Since you don't remember.
so then the magician will put the finger inside, take out the whole twist.
So look
That
at the whole
seems
test tube
spectacular,
inside.
right? You did not know that every magic trick is like
So
that.
what we did in the video.
But I do it as a magic trick.
So your audience then has to be a mixture of 2 and 3-year-olds. If you ever want this experiment to be successful as a magic trick.
If I had not told you the background of refractive index, you would not have been able to explain.
If you put in the broken test tube and the broken test tube disappears, obviously they're dumb enough now.
What?
They're not as dumb to
The broken test tube, look at it. The broken test tube dissolves in this magical liquid due to the chant. And then, the moment I put the finger inside and take it out, it comes out whole. That is the magic. So of course magic does not. So okay, then you have to explain, right? If it's not magic, you have to explain. What does it mean to the refractive index? Okay, now let's go.
So let's stop. Okay. Push that one down. Drop the other one down.
Two broken pieces.
I see it.
Stir this around a little bit.
Now he's stirring it.
Sir, he's banging the straw onto that only.
So you put the broken pieces, they disappear.
Tweezers.
And
See
then
what I
he's saying
can
he's
find.
stirred it. And then he takes a fork.
And there it is. There's my test tube back in one piece.
This is the magic.
At least that's how it appears. Take a closer look at that container.
Oh my God.
Sir, here is your audience of 2 to 3 year olds.
Understood or not? That's exactly what I've been telling, that the whole point of the magic trick is, before I open this trick to the audience, in the corn oil beaker I've already put the whole test tube. So it's invisible now. You can't see it. Now I say, I have a beaker filled with corn oil and I am going to add this broken beaker, a broken test tube into it, and then when I pull out the whole test tube. Clear? Okay, now let's learn the detailed theory. What?
So what is the light that the such that it goes in the same direction as
Light can bend only if there is a difference in optical density.
So what if the test tube is red in color?
Then you will see the red color. So that thing will fade. You can see the color difference with the oil. Do people listen to me explaining physics or do they listen to you singing?
What a guy, sir.
This is not the right time to sing. Around music will start that time to sing. Okay, so we'll all listen to you playing the instruments at that time. Now, please.
So are you coming for dance tonight?
Yes, of course.
So I'm dancing, sir. I of course.
I will come. Of course, because people are going to perform so wonderfully. I want to enjoy it. They call all right. You are coming exactly like in the play, all beaten up by the. क्या अलग अलग हुआ है भाई? Different obviously like dependent obviously you will see the different objects. So from this side it will appear the same. From this side it will appear the same because there is no change in the final result. Okay? Yes. Yes. But you see from this side, then it will be having. You see from this side, this side it will be this side it will be okay. Okay, now I want everybody to be quiet. I have the things to step the accelerator. We have to learn some theory now. Go to your place. Take rest, I will explain. I will take questions at the end. Go ahead, go ahead. Notebooks out, please. I will check your notebook. If it's not there, whatever I am writing on the board, no, you can't go to. Go and take a seat. Take a seat. No. Take a seat. Okay, so Satya, kindly take notes. So first thing is definition. So please note down this definition. Refraction of light refers to bending of light. Bending of light. Once I finish writing, I will erase everything and then I will come to your notebooks and check who has not written. And I will not listen to any excuse that you didn't get time to write. Please write.
Yes, sir. Will you tell us what's coming?
I will not tell you right now because you are disturbing me. I will tell you when the time comes. Alright. So bending of light. Bending of light. Incident obliquity. That's what I want. Bending of light incident obliquely on the interface between two media of different optical density due to change in speed. So let's have a look at this example. So suppose, guys, please. No talking, please. So suppose this is the interface. I will erase everything I am telling you the moment I finish. The moment I finish, I erase everything. So this is the normal. Normal is perpendicular to the interface. Samay, please take notes. And let us say this is the incident ray. So angle of incidence is the angle between the incident ray and the normal through the point of incidence. Okay. So if this was the original direction, it will bend. Let us say it bends away from the normal. So the angle which, so this is the refracted ray. Arab, please take it down. So this is the refracted ray. The angle which the refracted ray makes with the normal is the angle of refraction. This is the angle of incidence. And this is medium 1. So always medium 1 refers to the medium containing the incident ray. Because what comes first? Incident ray or refracted ray? Incident ray. So the incident ray will be, the medium containing incident ray will be called medium 1.
I have a very important question.
After I finish.
No, that related to the.
After I finish, I will take your question. Kindly be patient.
Okay.
So medium containing incident ray is medium 1. And medium containing, this is medium 2. So medium 2 is medium containing which ray?
Refracted ray.
Refracted ray, very good.
And the medium 2 is denser in this case.
No.
It's rarer.
So whenever a ray bends away from the normal,
It's rarer.
it is speeding up. So speeding up, ray is speeding up, then it will bend away from normal. So if the ray is slowing down, it will bend towards the normal. All this should be in your notebook.
Now erase it.
So all of it is my notebook.
Take it, give me your parents' email and write in a big piece of paper and give it to me.
So when the rays speeding up started bend,
Yarundra,
so you are
Arnav Chaudhary.
inevitable, but I am Iron Man.
Arnav Chaudhary.
I agree.
Okay, Aryan Chaudhary.
So,
Good morning.
so you are inevitable,
Take
but
this
I am
now.
Iron Man.
Instead of the number
Take this straight.
So,
Take it, please sit straight.
so,
Sit straight, please.
so, you are inevitable, but I am Iron Man.
Okay.
Sir, in the definition, instead of the number 2, can we write 2 in words?
Iron Man.
Right?
Can we write it?
Yeah.
I have the most important question
So,
in the world.
I will take it after I finish this concept. I haven't finished.
Promise, you took their question, you took his question.
You didn't ask me question. He made some nonsensical statement.
So he asked you a question.
Sir,
This is not fair.
If ray is slowing down,
Sir, obviously फिर उल्टा होगा.
you have to write it in your notebook.
I don't like you as
I see.
Words normal. Okay. Then notebook is not there and even the notes are not complete.
So now may I
All these points are not there. Wait, yeah, I'll take it. Be patient. So in this case, if the ray is speeding up, we call that medium as rarer medium. Rarer medium, which means lower refractive index.
So this means medium 2 is rarer medium.
Yes. Since it is going faster, so see here, the analogy is like this. Suppose you are running, and right now you are running through air. Suppose, yeah, you are running through air. So the air is a very rare medium. The particles are spaced out diffusely. But suppose I suddenly use my magic wand and make this surrounding into a jelly. Then to run through jelly will be difficult. So it is optic. It's like dense medium. So you can run fast.
running through water.
Yeah, running through water is also difficult. Running through jelly is also difficult. Please, yeah, focus on what I'm trying to explain. Basically, if the medium becomes denser and denser, it becomes difficult to travel through it. You will get slowed down. Same logic we are using to explain optical density. Optical density is referring to the slowing down of light. Optic is for light. So if a medium makes light to slow down, for light the medium appears very dense.
Sir, but हम side में तो नहीं घूमेंगे.
So is space medium.
I will explain. Even listen here.
Yes, space medium.
Now I am explaining to you
Sir,
why.
use that car.
Mr. Astronaut.
I don't like it when you interrupt when I'm in the middle of an explanation.
So,
I haven't finished explaining. Can you please let me explain?
Why you there?
I just told you some facts. Now you need to understand why it happens. I'm explaining. So whenever it speeds up, it bends away from the normal. You don't know why. So I will give you one example of real life. यार एक तो बोलने दे पूरा. So it bends away from the normal when it is speeding up. So let me give you one real life example where such a thing happens. It will give you some way to digest this fact. So suppose you have a rough surface. And here you have a smooth surface. So this is like a smooth road. This is full of bushes, shrubs, boulders, rocks and all that. And you have a toy car. A toy car which has a motor and a battery inside it. So the toy car will have a particular fixed force. The engine will have a force which it can exert, and so it will have a certain speed with which it can go. Okay. So on this rough surface there is a lot of opposing force. So its speed will be high or low? Low. But once it crosses to the smooth surface, it will go fast because the blockages, obstacles are less. Here imagine it's all very tall grass. Grass is very tall, so it has to push the grass aside and then
So, but
walk through it.
this does not explain the reason why it moved away.
I haven't finished, impatient fellow. I haven't finished, be patient.
Impatient.
So right now, here it will be slow, here it will be fast. Agreed? Now see how the bending part will be explained. Look carefully. Look carefully. So let us say right now it is going at an angle. So this direction it represents the incident ray. So when it reaches here, these are the wheels. So this wheel will first cross over into the smoother surface, and this wheel is still continuing in the rough surface. All the four wheels are powered by the same engine only. So when this wheel comes into the smoother surface, suddenly the resistance will be less, its speed will become more,
Yes.
so it will travel more distance. But this wheel will not travel fast, it will continue to travel slow. So this wheel will travel less distance, this wheel will travel more distance, so automatically the vehicle will turn. Are you getting it or not? Listen carefully. Imagine my two hands, my fists on the wheels. This wheel is going slow, only this much. This wheel is traveling fast. Automatically I turned or not? If one wheel travels more distance, I will end up turning around the slower wheel.
Yeah.
So this front part of the vehicle will become like this. And then once this wheel also comes to the fast surface, both the wheels will travel at same speed. If two wheels travel at same speed, they will no longer turn. They will continue in a straight line. So now it will turn, it will travel like this. So I have 1 minute. So these are the four wheels. So the toy car which was going straight in this direction, it ends up bending like this. So this is the normal. So it has bent away from the normal.
So this.
Okay, once again. Now you are telling me what you don't understand in this.
Sir, let me
Yes.
tell you. Sir, light doesn't have four wheels. This is revolving around.
I said it is not the actual explanation of why light bends. It is just something similar happens. At least you can see something which happens in real life where bending away from the normal happens for speeding up. So that you can at least accept it, be comfortable with the idea.
Okay.
The actual explanation is not possible to give.
But I have one more question. Sir, we write the angle of reflection as R, right? Small r, right? Refraction.
That's the angle of reflection.
Pause it.
Hello, sir. कैसे हो?
Stop like that, it's not good manners.
Sorry.
Yes.
We write the angle of refraction as small r, and we also write the angle of reflection as small r.
Yes.
How does that make sense?
It doesn't make sense, but it shows the faith and trust they have in you. They feel that you have enough common sense and intuition to understand by context which means what.
Yes, sir.
When light undergoes reflection, R means angle of reflection. When light undergoes refraction, R means angle of refraction. They expect you to be smart enough to figure that out. Okay.
Come on, sir.
Yes, Aryan. Alright.
So to sum up, we say that the refractive rays will bend away from the normal current, move from lower higher density medium to lower density.
Yes.
And it will bend towards the normal current, goes from lower density to higher density.
Yes. Your question.
Third, do we call higher density medium, rarer medium or something like that?
Higher density medium is denser medium.
Denser medium.
Optically denser medium. Lower density medium is rarer medium. Please no snubbing. You have to be tolerant and accepting of everybody.
So he said denser को रह रहे पूरा क्या?
So,
It's okay, man.
Is it okay?
You have to accept it. You should not react like
very
this.
bad. So you taught us
Today's video I cannot share, I think.
So,
Lot of interruptions.
So R, G, E, and C, Y. So yellow is beat, blue is not there.
It is irrelevant to our discussion right now. Please, I will not take it now. I will not take it now. It's an irrelevant question. When we discuss color theory, that time I will take it. Okay, any other question? Avi, what's your question?
So I know this explanation and lot of words, but what if the car is going straight?
Then you won't find any bending.
That's what.
That's why when I define refraction, I would say oblique incidence. If the car is going straight, it will continue straight. So this is a very good analogy. If light is going straight like this, it will slow down but it will not bend. So the bending is observed only for oblique incidents. And this car example works even for that. That's why it's a very beautiful analogy, but it's not the reason for light bending. Because car is not light, as I pointed out.
What is the reason?
But that is not easy to understand.
Wavelengths.
It's not easy to understand. Okay, what is the reason you wanted, right? I can explain. By Huygens principle of secondary wavelengths. You will learn it formally in 12th ISC physics. Now, if I teach it, it will be taking up your
You
time.
told us about one secondary.
For diffraction, I told you, right?
Yeah.
Same way you have to draw the wavefronts.
Okay.
So, if you make the wavefronts in the second medium,
Okay.
smaller radius. Why smaller radius? If it goes slower, it will, at the same time, it will travel less distance.
Yeah.
The wavefront will travel less distance.
Yeah.
So then it will end up bending
Acha, then it
towards.
turns this way.
Yes.
Okay, got
Right,
it.
sir?
You are very smart. That means without drawing it, you understood so quickly.
Sir?
So you, by in 12th ISC, you will actually do the drawing and you will see that it bends.
Yes, sir, I get it.
Got it? So that is a true explanation. But now at your level, we explain it using this analogy. Yes.
Sir, could you just explain what is refractive?
I will explain. I haven't defined it properly yet. Okay, so till here is clear. I am erasing this. Pause the video. Pause, not stop. No, no. Yeah, what is your doubt?
So RGB and CMY. This means that
This was not mentioned in the video.
जैसे वो पूछेगा ब्लू टेस्ट ट्यूब बोलते क्या होगा?
Blue test tube would appear blue in the through the liquid, so it won't appear invisible.
अरे ट्रांसपेरेंट में होता है बस.
Okay? Clear? No, go ask. It's okay. You can ask. I'm anyway erasing the board.
Yellow.
Yeah, please do that. I'm already very tired.
Same.
Inside, it could be a blue light.
भाई हर चीज़
Suppose like family those it's giving out yellow light. So R and G form yellow, red and green. So does this mean that like the blue light which is of the test tube, it will also be absorbed by the conveyor?
When something appears blue, it doesn't mean that the object is emitting blue light. It just means that it is appearing blue in white light. White light is falling on the blue object, and blue light is getting reflected back. All the other colors, red and green, are getting absorbed. That's why it's appearing blue. Out of what? See, white light is a mixture of red, green, blue. So red, green, blue falls on the blue test tube, and the blue test tube absorbs red and green and reflects only the blue. So it was appearing blue. So now what is the question? Okay, what you are saying is the reflected light or transmitted light through the test tube which is blue, when it passes through the yellow oil. Okay, wait. Yellow oil. RGBCMY. So when the blue light travels through the yellow oil, yellow means it absorbs blue, so it should not be, so it should appear colorless. That's what you're asking. Yeah, good question. Yeah, it will appear.
It would appear colorless.
So blue test tube would appear colorless.
So it would be like it would appear.
So you can try it out. You can take a slightly transparent, you can take a transparent blue test tube, bluish tint. You can take a transparent blue tinted test tube and put it in yellow colored corn oil, it should appear transparent. It should appear invisible. Yes. Yes, good hypothesis. Okay? According to the physics color theory, it should appear invisible. Yes. Okay, now let us go into more detail about refractive index. Notes. Uday.
So 1 minute is left, so please don't do that.
Every minute is important.
When it's left, so please don't do that.
Refractive index N is defined as, I will not repeat it next class. Speed of light
In vacuum.
in medium.
Medium upon
Speed of light in vacuum.
Yes, sir. In vacuum upon
Speed of light in vacuum.
vacuum.
Vacuum upon
So we add this.
speed of light in medium. That is C by V. So it is always greater than 1. Are you getting it? See, speed of light in vacuum is always greater than the speed of light in the medium. So refractive index will always be greater than 1. This is called absolute refractive index of a medium. Absolute refractive index of
So what have you written in the brackets over there?
So my
bracket I have written C.
So what is C?
Speed of light in vacuum.
We should have y is equal to
Speed of light in vacuum is called as C. I don't like these kind of spiteful responses. This kind of spiteful responses is not a good habit. I have to be polite and friendly. Please stop the recording.